Hanggang ngayon mga kapamilya ay usad pagong pa rin ang traffic sa Baguio City.
Dahil sa tindi ng traffic.
Grabe yung traffic kanina. Ayaw at akong pauwiin. Hala, kapit na kapit yung apoy ng usok sa damit ko. Eh, hindi naman ako nagtagal sa labas. Yes? Ba't ka tumatawag?
Nakauwi ka na ba?
Oo. Grabe talaga yung traffic sa Baguio, te. Amoy usok pa ako.
Kaya nga hindi naman takpan ng pabango ko yung kahapon.
It is no doubt that what Jaden and Yvette showed here is a daily occurrence for the locals of Baguio. Although efforts from our city government are being observed, it would also be a good practice for citizens like us to contribute our own ways to help improve our city.
With that, we will be presenting a concept vehicle that our group came up with, keeping in mind the challenges Baguio is facing, particularly traffic and above all, air pollution. To start everything off, let's take a look at the vehicle we designed.
We drew inspiration from the jeepneys of the Philippines because we believed with progress, one must never forget their roots.
Our design focuses on helping reduce traffic. The length of our vehicle was planned to accommodate more commuters, so fewer vehicles would be needed on the road, hopefully reducing congestion.
For the fuel use, let's call on Yvette and Jaden to explain it to us.
Unlike most vehicles here in Baguio, our vehicle will use biodiesel as it burns clearer, is biodegradable, and non-toxic.
It's made from vegetable oil, animal fat, or used cooking oil. It's produced through transesterification and can either replace or be blended with regular diesel.
You might be wondering what transesterification is. It is a process where oil and fat is mixed with alcohol and a catalyst to produce biodiesel and glycerin. Basically, it converts oil into fuel.
There are many biodiesel blends: B5, B10, B15, B20, and B100. Just to name a few, the B stands for biodiesel, and the number beside it indicates the percentage of biodiesel in the blend.
Our vehicle will use the B5 blend, meaning it contains 5% biodiesel and 95% petroleum diesel.
First, let's understand why biodiesel is different from regular diesel. Regular diesel is mostly made of hydrocarbons, which are long chains of carbon and hydrogen atoms without oxygen.
Biodiesel, however, is made of fatty acid molecules called fatty acid methyl esters. These have an ester group which contains oxygen.
Even though it seems like a small change, this oxygen and the molecular structure affects how the fuel behaves in the engine. Because biodiesel molecules contain oxygen, they burn more completely during combustion.
In chemical terms, the oxygen in the fuel helps it react fully with the air's oxygen, producing more carbon dioxide, water, and less unburned fuel. This means reduced soot, black smoke, and harmful gases like carbon monoxide and hydrocarbons.
The long, mostly straight chains of biodiesel molecules make them easier to ignite. So combustion starts faster and runs more smoothly.
Even though biodiesel has slightly lower power per kilogram than petroleum diesel because of the oxygen mass, the improved combustion efficiency in a B5 blend means the engine loses very little power while emitting cleaner exhaust.
Moving on, since Baguio is situated in the highlands, tight and banked roads routes like Cannon Road and Marcos Highway are unavoidable. Safety and stability are of utmost importance, especially since our vehicle would operate as a public utility vehicle.
Let's call on Ariel and Janelle to explain to us how this would be achieved.
Imagine our vehicle fully loaded on a hairpin section of Cannon Road. For a jeepney with a mass of 2,000 kilograms approaching a curve with a ratio of 25 meters and a bank angle of 12 degrees, here's what we found.
The 12-degree banking angle was designed to help vehicles turn. We calculated the theoretical no-friction safe speed for this curve, which is the speed where the road alone provides all the necessary centripetal force. Our formula for this speed is the square root of the quantity, the radius multiplied by the gravitational acceleration multiplied by the tangent of the bank angle theta, which is just the angle of the bank.
That speed is only about 7.22 meters per second. If our vehicle enters this curve at a high speed, say 11.11 meters per second, the road's banking isn't enough. Using the formula of centripetal force, which is the mass multiplied by the velocity squared divided by the radius.
At that high speed, the required centripetal force jumps to almost 9,875 newtons. To prevent the vehicle from skidding outward and off the road, the tires need a lot of extra grip.
That's why a disciplined driver is key. Our scenario assumes the driver brakes for 2 seconds to slow down before entering the curve, reducing the speed from 11.11 meters per second to 2.50 meters per second.
To calculate the force of the brake, we would first need to find the impulse. We can find this by multiplying the mass of our vehicle by the difference between the final velocity and the initial velocity. This gives us the value of 7,220 kg/meter per second.
That braking action requires a powerful average force of 8,610 newtons. We can get the brake force by dividing the impulse by the time taken. The braking force of the 11.11 meters per second speed would be an extreme 8,610 newtons, for more than what a single person would produce in a matter of seconds. More importantly, it removes over 117 joules of kinetic energy, as it is converted into heat at the brakes. This is calculated by subtracting the product of 1/2 times the mass times the final velocity squared from the product of 1/2 times the mass times the initial velocity squared.
By slowing down to 2.50 meters per second, the required centripetal force drops dramatically to just 500 newton, ensuring maximum stability and safety to the hairpin. Our concept vehicle addresses 3 concerns.
We track traffic congestion with an efficient, high-capacity design.
We addressed air pollution with a clean-burning B5 biodiesel blend.
And we ensured commuter safety by using physics to validate operating procedures on challenging mountain terrain.
This is not just a concept vehicle. It's a blueprint for sustainable and safer public transport that would surely drive Baguio 1 mile forward.